Hello friends, this is Dr. Hemchand Kothari from eResearch Academy. Friends, I welcome you all in my YouTube channel. So today we are going to cover a new topic, that is mode under the measures of central tendency. Though we have covered the first two topics under measures of central tendency, these are mean and median. Now we are discussing the topic mode, and here we will discuss all these three series here, say individual, discrete and continuous. So let's start. So first we will discuss what is the mode. Actually, mode is defined as most occurring or most repeated frequency in any frequency distribution. Okay, so the word mode is originated from the Carl Pearson's distribution, when he first used this term in his distribution in 1895. Okay, and other than in his work, this word is also used in French expression a la mode, okay, which means a most fashionable. So if we just take idea from there, it means mode is a number which is most fashionable or most popular in any population distribution or a statistical series or in any sample distribution, right? So mode is most repeated or most fashionable value or frequency in any frequency distribution or population distribution or sampling distribution. Okay, uh, if you talk about the usage of the mode, it is a statistical tool which is used to identify most favorable, most preferred, or most demanded item. Say, most demanded outfits, shoes, watch, bags, car, ice cream, cakes, etc. Right? So, whatever the item which is most demanded or fashionable in the population or in any area or in any country, we can say that item is the mode item of that particular area, country, or the items, right? Okay, now we will discuss mode in all these three series, say individual, discrete and continuous one. We will start from the first series, that is the individual series. So under the individual series, to find out the mode is quite easy. Okay, easy here means we have only to observe the given frequencies and we have to just find out the most repeated item or most occurring item in the series, right? So if we consider this question, that find out the mode from following frequency, so we are given some frequencies here, say some values here with their frequency, the 5, 10, 4, 5, 4, 6, 8, 9, 5, 4, 8 and 5. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 values. Okay, and we will have to just count the frequency of each individual item. Okay, say 5 is occurring once, second, third, four time, so 5 is occurring four times. Okay, and 10 is only once, 4 is one, two, three times, and 6 is only once, 8 is only one time, sorry, two time, and 9 is only one time. So by this observation we can only identify that the 5 is repeating most of the time, say four times, so that is why our answer will be 5. Okay, so the answer is 5. So in individual series we only observe the given values or the given frequencies or items, so we can easily identify which one is the mode item. Okay, so here 5 is the mode item because it has the highest frequency 4. Okay, so next one, that is the mode in discrete series. So same as individual series, in discrete series, though we have the frequencies for every item or size is given here, so this is more easy as compared to individual series. In individual series we have to count, but it is more easy that we have to we have given the frequency of individual item in this discrete series. So we have only to observe the frequencies. So by observation, what we are observing here, the question is calculate mode from the following data. The first column we have size of cake in pounds, and second column their quantity demanded, means their frequency. So 1 pound, 2 pound, 3 pound, 4 pound and 5 pounds cake size is there, and we are observing that the cake with 2 pound is demanded most. Okay, again I'm highlighting it. The cake with 2 pound is it demanded most, hence 50 times. Okay, so by this way the mode weight or cake is of 2 pounds. Okay, so this is the answer of this question. So this is very easy to find the mode in discrete series. Okay, so next one, mode in continuous series. So this method, or say the mode in this continuous series, a bit tough as compared to the first two series, because here we have to apply a formula, and the formula becomes mode equal to L1 plus F1 minus F0 upon 2 F1 minus F0 minus F2 into I. Okay, and another formula also we have, that mode equal to L1 plus D1 upon D1 plus D2 into I. Okay, so let's talk about the this second formula first, because this formula I'm not just here in this lecture, though we are just solving the question here with first one formula. So but we will have to understand the meaning of the second formula as well. So L1 here means the lower limit of the model group or model class. D1 is the first difference. Okay, and this is simply F1 minus F0. F1 means frequency of the model group minus frequency of the preceding group of the model group. So this is the D1 or difference 1, and D2 here means the difference between the frequency of model group minus frequency of succeeding group of the model group into I stand for the value of class interval. Okay, so we will either apply this formula or this formula, the answer will be the same. Okay, so if we talk about the question here, so if we talk about the abbreviation of these denotation, so in first formula here L1 here means lower limit of the mode group or model group. F1 means frequency of mode group, F0 frequency of the group preceding to mode group, F2 is frequency of the group succeeding to the mode group, and I equal to size of class interval or value of class interval, right? So now let's take an example here. So this is a question where we have to calculate mode value from the following marks or their frequencies or number of students. Okay, and we will apply the first formula in this question here. Okay, so let's start. So the first thing what we have to do in first step, we have to identify a group which has the most repeating value or highest frequency. So here by observation we identified this group 20 to 30 which has the highest frequency 15. So our model group will be 30 to 50. 20 to 30, right? So 20 to 30 will be our model group. Okay. So if we talk about the abbreviation of this or notation of the formula, this 20 is L1. Okay, 20 is L1 here, right? This 15 is our F1, right? And this 12 is our F0, and 10 is our F2. Okay, sorry, the battery is a bit low. Anyway, So this 8 10 is our f2, right? So and our class interval is 10. Okay, the difference between all classes is 10. This is equal for all. Okay, so let's put all the values here in formula, see what we get. Now put the values in our formula. So this is, so 20 plus 15 minus 12 upon 2 into 15 minus 12 minus 10 into 10. So here 20 is our L1. So lower limit of our model group is 20 to 30. Okay. So this is our model group, and 15 is our F1, means frequency of model group. 12 is the frequency of preceding group. This is F1, F0. 2 into 15 is our F1, 12 is our F0, and 10 is our F2, means frequency of succeeding item into 10. Okay. And when we solve it, it becomes 20 plus 3 upon 30 minus 12. This is 15 into 2 30, and 12 plus 10 22 into 10, and then 20 plus 10 into 3 30 by 30 minus 22 8, and this is 20 plus 30 by 8 equal to 3.75, and our answer becomes 23.75. So our G value, or Z, or simply MO or mode value becomes 23.75. So our model marks or mode marks are 23.75 in this question, right? So by this way we calculate the value of mode under the continuous series. Okay, so in this lecture we have just learned how the modal value is calculated under individual, discrete as well as in continuous series. So friends, thank you for watching this video. Have a nice day ahead. God bless you. Thank you.